Welcome Calculus BC. This is lesson 3.6, Antiderivatives. The essential question is, what are some unique ways to pronounce Antiderivates? Let's go. So, differentiate each of the following. F of x, x cubed would be 3x squared, and derivative of this would be 3x squared, and derivative of this, where c is a constant, is 3x squared. They're all the same. So what do you get when you anti-differentiate? Which of these three? I don't know. Maybe it could be any of those, but it's just a different constant right here. So that's the point. The problem when you're solving these things, and you integrate this or anti-derive, is x cubed plus c, where c is any constant. And we use this little elongated s thing to symbolize integration. And when you have integration, you want to do that thingy, and then you have to put the dx there at the end. What does the dx indicate? That you're integrating with respect to the variable x, because maybe you integrate with a different variable, but we don't do that too often. C is your constant of integration because you always have a plus c when you integrate, because as you saw in that example at the start, we could have any constant at the end, and it would be the same when you anti-derive like that 3x squared. So we use that to represent, hey, we don't know what it is. It could be anything. And that's the weird part of integration. There's that part that you don't know what it is. So some rules. The power rule. So integral of x to the n dx. This is just backwards power rule. So if I said the integral of like x to the 5th dx, it would be x to the 6th, add 1 to the x, then divide by the new exponent 6, and then the plus c. All right? And n can't equal -1 because just think about that. Constant rule. So if you integrate a constant, you just multiply it by an x and put the plus c. So the integral of pi, which is a constant dx, would be pi times x plus c. Okay. Other rules. Scalar multiple rule. So if you have like a constant being multiplied by a function, when you integrate it, you can put that constant on the outside. Basically, you just multiply that by the integration of whatever you're doing. Okay, so you may factor out those constants, but never factor out a variable. Shame on you. So let's say I do the integral of 5x dx. Well, I could rewrite that as 5 times the integral of x dx, and the antiderivative of x is going to be 5 times x squared over 2 plus c. So I could write this as like 5x squared over 2 plus c, something like that, and I'm right. You know, and you could take this backwards if you ever want to derive it, and you would get back to 5x. All right, some rule says, hey, if you have different terms being added or subtracted, you can integrate each separately. So I have the integral of 5 plus 2x dx. We'd integrate, that's the integral of 5 dx. Plus the integral of 2x dx. Integral of 5 dx is 5x. Integral of 2x is going to be 2x squared over 2 plus c. And you could cancel out those 2's. So you just do each term separately. Same thing with derivatives. Okay, trig rules. Remember the sine, cosine. So sine, cosine, negative sine, negative cosine. This was derivatives going this way. Going backwards is the antiderivative. So you just go backwards. So integral of cosine is sine. Integral of secant backwards is going to be tangent of x. Integral of secant of x tanks is going to be secant of x. Oh wait, the plus c's. Integral of sinks is going to be negative cos 6 plus c. Cosecant squared is negative cot x plus c, and cosecant cot x is going to be negative cosecant of x plus c. Okay, some examples. Do more. That's x to the 4th over 4 plus c. This is 2x plus c. And then integral of both these separately of cosine would be 2 times sine of theta minus 3 times cosine of theta, or plus, because you got to flip the sign on this one, plus c. There you go. Oh, so sometimes the initial condition is given, so we can actually solve for c. So if we have this as my f prime of x to the negative 3, and f of 1 is this, find f of x, that means we have to integrate x to the negative 3 dx, which is going to be x to the negative 2 over negative 2 plus c. That means that's our f of x equals this thing. And if I know my f of 1 equals 3/2, that means I have when x is 1, y is 3/2. So I can say 1 equals, ooh, this is kind of gross, but I can rewrite that as 1 over negative 2x squared plus c. And no, that 1 is not right. F of 1 equals this. So I'm going to say 3/2 equals 1 over negative 2 times 1 squared plus c, which is negative 1/2 plus c. Adding 1/2 to both sides, I'll get my c equals 4/2, which is 2. So I can write my final f of x as x to the negative 2 over negative 2 plus 2. Okay. And position, velocity, acceleration. When you derive positions, velocity, acceleration, I can go backwards when you integrate. And integral of acceleration is velocity and velocity is position. But remember that like plus c part, which ends up plus c is going to be like your initial velocity or initial position. So s sub 0 or s of 0. So that's what you have to think about sometimes. So just remember the plus c's. So for an example, acceleration of a particle at time t is given by this. And we have some initial conditions here. So this is going to help us find those plus c's. To find the velocity, I want to antiderive this. So it's going to be 4. It's going to be 4 times t squared over 2 minus 3t plus c, which I can rewrite as v of t is 2t squared plus, oops, not plus, minus 3t plus c. Well, I know v of 1 is 6, so I can say v of 1 is 6, which is 2 times 1 squared, or 2, minus 3 plus c. That's going to be negative 1 plus c, so my c equals 7. So I can say my v of t is going to be 2t squared minus 3t plus 7. All right, got my v, and now I'm going to find my position function, and remember my initial position is that. So you antiderive the v of t, so I get my s of t equals 4. Oh, no, don't do that. You're getting confused. 2 times t cubed over 3 minus 3t squared over 2 plus 7t plus c. And given my initial condition, s of 2 equals that thingy. So I'm going to say my s of 2 equals, I want to do this in brown, 5, which equals, okay, 2 times 2 cubed is 8 times 2 is 16 thirds. Oh, man, it's not going to be fun. Minus 12 halves plus 7 times 2 is 14 plus c. Ugh. So this is negative 6 plus 14, which is going to be positive 8 plus c and 16 thirds. Okay. Man. All right, so you got to subtract these things on both sides. Equals that 5. To solve for your c, so you're going to subtract minus 8 and minus 16 thirds. So 5 minus 8 is going to be negative 3 minus 16 thirds. Equals your c. Okay, I'm going to leave it like that because you can do that in calculus. So s of t equals 2t cubed over 3 minus 3t squared over 2 plus 7t minus 3 minus 16 thirds. This is legal unless I messed up somewhere. Yep, I think that's enough.